Hai, Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Syafiq Amir bin Jamrus and my partner Muaz bin Yasir want to explain to you all guys about result input and output we got. First, let me explain the input of the code we implemented. We start by defining the sampling frequency as 1000 Hz. This parameter determines how often we sample the signal, or in simple terms, how frequently we collect data point per second. Next, we calculate the sampling period by taking the reciprocal of the sampling frequency. This gives us the duration between each sample. In this case, the sampling period would be 1 millisecond. Moving on, we set the length of the signal to 1000. This means our signal will consist of 1000 data point or sample. It determines the total duration or length of the signal we are working with. And lastly, for the input, we create a time vector using the formula 0 same L negative 1 by multiplication T. This vector represent the time value corresponding to each sample in the signal. It helps establish the time exists for our signal, allowing us to analyze it in the time domain. So now let's discuss of the output we got. The output include several visualization and data representation. First, we have the plot of the noise signal. The signal represent the random noise added to the composite signal. By visualizing the noise waveform, we can observe its characteristic.
Version 2. Next, we have the plot of the original composite signal. This signal is the combination of three sine waves with frequency of 50 Hz, 150 Hz and 300 Hz. It represents the clean undistorted version of the signal. Eventually, we have the plot of the noisy composite signal. This signal is the original composite signal coupled with the random noise. By visualizing the noisy signal, we can see how the noise affects the overall waveform and identify any distortion introduced. Moving to the frequency domain, we calculate the fast Fourier transform of the noisy composite signal. This allows us to analyze the signal in terms of its frequency component. By calculating the unique frequency present in the signal and their composite magnitude, we can plot the frequency spectrum. The frequency spectrum provides insight into the frequency computation of the signal, showing us the distribution of frequency and their magnitude. In summary, the code provides visualization and data representation of the input and output signal. It allows us to observe the noise, analyze the composite signal in the time domain, then explore its frequency component in the frequency domain. That's all. Thank you.